Welcome back to the Inclusive Mathematics Professional Development Series. I'm Dr. Tara Kezarowski, and next up we have Module 2, Mathematical Learners, and the impact of different disabilities on learning mathematics. This module will focus on this question: why do some students struggle with math? By the end of this module, you should be able to explain what dyscalculia is and how it may impact a student's mathematical understanding and performance. You will brainstorm other disabilities that may impact learning math, as well as some broad strategies for supporting learners with disabilities. Finally, you will be able to describe different types of assistive technology that may support learners with disabilities in accessing the math curriculum. In the world of special education, dyscalculia is what we call a specific learning disability in the area of mathematics. In this module, I will use dyscalculia and mathematics learning disability, MLD, interchangeably. Specific learning disabilities are one of the 13 disability categories under IDEA. We say specific because they often manifest themselves in the areas of reading, dyslexia, math, dyscalculia, and writing, dysgraphia. There is also a form of LD called a nonverbal learning disability, which is characterized by a large discrepancy between higher verbal skills and weaker motor, visual-spatial, and social skills. Dyscalculia, also known as a math learning disability or a mathematics disorder, refers to a brain-based condition that makes it hard for someone to make sense of numbers and math concepts. One of the most common difficulties is with number sense. Number sense is an intuitive understanding of how numbers work and how to compare and estimate quantities. Poor number sense makes it difficult to connect numbers to the real world. For example, a child with dyscalculia might have trouble understanding that 5 cookies has the same quantity of objects as 5 pencils or 5 apples. Someone with dyscalculia may have difficulty subitizing, which means recognizing quantities without counting objects one by one. Additionally, someone with a math learning disability may have difficulties in recalling math facts, linking numbers and symbols, mental math, estimation, telling time, visual and spatial orientation like directions, and recognizing patterns. Dyscalculia is much less known in research than dyslexia. We are not exactly sure how many students have a math learning disability because not every state and district specifies the type of LD when they diagnose it. A good estimate is approximately 6 to 8% of elementary school children having dyscalculia. It's also not uncommon for students to have difficulties in more than one area. Over half, about 56% of kids with a reading disorder, also have poor math achievement. And between 43 and 65% of kids with a math disability also have poor reading skills. This is likely because of the characteristics and causes of learning disabilities. This chart is a visual description of the factors researchers have identified that influence the performance of students with mathematics learning disabilities. Essentially, we can divide those factors into student factors and environmental factors. The student factors can be academic, like using underdeveloped strategies, having poor number sense, and weak listening or reading comprehension skills. There are also certain cognitive impacts on working memory and attention that typically characterize people with MLD. In mathematics, this makes simple fact retrieval a challenge. When it comes to problem solving, we all need to be able to recall facts and procedures and the underlying mathematical concepts, and then apply those to solve a problem. Students with dyscalculia have a hard time doing this without some support. Lastly, self-regulatory needs are also common among student factors related to poor mathematical performance. Students with MLD tend to have weaker self-monitoring strategies, organizational skills, and self-efficacy. The environmental factors are related to instruction and the logistics of today's classrooms. By no means do these environmental factors cause a learning disability, but they definitely can add to a student's struggle. Many teachers feel ill-prepared to teach math to students. New standards feel more fast-paced and rigorous, and elementary teachers especially do not have a lot of training on the subject. This leads to teacher misconceptions and ultimately more confusion for students. In general, the National Mathematics Advisory Panel found that many teachers are not using evidence-based practices in their classroom to support students with disabilities. If most students who struggle with math are placed in general education settings like we know, we need to make sure teachers are prepared with the math content and evidence-based math pedagogy to support them. Lastly, the logistics of today's classrooms, like larger class sizes and more students with disabilities placed in the same classes, means less time for teachers to meet the needs of all of their students. Dyscalculia, or a math learning disability, is not the only type of disability that may impact a student's performance and understanding of mathematics. Take a moment to pause the video and brainstorm other disabilities you know of and how they might impact a student in math. Students who are hard of hearing or deaf may have difficulty accessing math content. Though much of math is visual, we generally pair that with verbal explanations. Our deaf learners may use ASL to communicate, so a translator may help. However, many students who are hard of hearing still use listening and spoken language to some degree. It's important that visuals are plentiful and clear. Your explanations also need to be written out, and you need to give students the time they need to process auditory information. Conversely, students who are blind or visually impaired may need clear verbal explanations. They also tend to use concrete physical manipulatives and/or tactile images for visual information. Many other disabilities can impact someone's learning in math, just like any other subject area. Disabilities like intellectual disabilities or ADHD may impact cognitive processing or the ability to focus. Other physical disabilities may impact the way a student interacts with manipulatives and other learning tools in math. Speech and language disorders may impact the way a student can verbalize their thoughts and understandings. Generally, following principles of universal design for learning, meaning providing multiple means of engagement, representation, and action and expression, can increase the inclusiveness of your math instruction. Another way to support learners with disabilities in math is through the use of assistive technology, or AT for short. As a quick review, AT refers to any piece of equipment or product system, whether acquired commercially off the shelf, modified, or customized, that is used to increase, maintain, or improve the functional capabilities of a person with a disability. AT can also include the services used when considering, evaluating, and implementing the devices. Generally, AT gives people with disabilities a means of access, communication, and even entertainment that wouldn't otherwise be possible due to their disability. Remember, AT does not give the person with a disability an advantage in school or life over other students. In schools, AT consideration is required for all students with disabilities to make sure they are given the same opportunities for learning as their non-disabled peers. When thinking of assistive technology, we should think of technology as any human-made tool that changes the way we do things. These tools will range from low-tech solutions like special pencil grips, glasses, or a slant board, to more high-tech solutions like special computer software or devices used for learning and communication. We all use many types of technology or tools for a variety of instructional reasons. However, people with disabilities often need or require additional or customized technology defined as assistive technology to enable them to perform activities in ways similar to their non-disabled peers. AT is decided by the IEP team and then incorporated into the IEP documentation. Let's review again. How might a disability impact a student's access to the math curriculum? For one, students need strong receptive skills, like understanding concepts, reading math, both word problems and mathematical notation. Reading math can be impacted by all kinds of disabilities, such as sensory impairments, cognitive impairments, physical impairments, and learning disabilities. Math also requires expressive skills like writing, drawing, measuring, graphing. Different disabilities may impact a student's ability to engage in expressive math tasks in different ways. Students need to be able to read in math. They may require low-tech options like a reading guide to help them keep track of the lines as they read. They may need low-tech magnifiers or high-tech screen magnifiers. They may also need text-to-speech software like Kurzweil or Read Out Loud. Many of these features are built right into computer and tablet operating system these days. I recommend making all of your digital materials using selectable text rather than using images of words so that specialized software like these are able to accurately read the content. Students may require specific devices to express their answers in math. This may mean voice dictation, using specialized writing tools or grips, utilizing graph paper to help line up their numbers, or using number stamps for students who do not yet have the fine motor skills to form their numbers. Using tablets for instruction, students can drag, drop, and click some of their responses when writing isn't an option. There's also some software that's designed for writing math that includes simple ways to write symbols, shapes, and equations using a computer. High-tech options often work with specific switch devices that students need as alternatives to clicking depending on their physical abilities. Technology can be used to support math concepts. Concrete and virtual manipulatives are helpful forms of technology to support students as they learn new concepts. The line between assistive technology, AT, and instructional technology, IT, begins to blur as we utilize these kinds of tools. For some students, manipulatives are considered instructional technology, but for others who may need these tools to access the content due to disability, they would be considered assistive technology. Some students require seeing information in multiple ways or frequent review, particularly during independent practice. You could utilize apps like EduCreations or Explain Everything to draw and record auditory directions or procedures for students. These videos can easily be embedded onto digital assignments or linked as QR codes on paper assignments when a student needs some extra review. Students can even make these videos themselves or for each other. There are all kinds of tools available to assist with computation. These could be low-tech, like counters or an abacus. They also include different kinds of calculators, like large key, handwriting, and talking calculators. Allowing students with an intellectual or learning disability to utilize calculators can be necessary to offload working memory tasks so that they can focus on higher-order problem solving. Talking calculators are nice to help students keep track of what they typed, and they're nice for students who might see 5-1 and interpret it as 15. There are even some calculator apps that allow students to handwrite simple equations, even in fraction form, and it will calculate the answer for them. This could make a nice check for students who struggle with the calculations they need to apply to more complex problem solving. Students who struggle with decimals or who have trouble remembering the values of different coins may be able to solve problems involving money when using specialized coin calculators, money manipulatives, or apps. Measurement is an area of math that is highly relatable to the real world, particularly in the areas of building and cooking. Some students with physical disabilities may need specialized tools to help with challenges related to mobility. For conceptual support, the rulers in the top corner are transparent and they can be flipped to build on the concept of measuring to the nearest half, quarter, eighth, and finally 16th inches. This might help students who are having trouble finding the correct marks on the ruler as well. Time is a challenging concept in math. Some students may need clock manipulatives to help them understand the relationship between minutes and hours. Visual timers are great tools for students who struggle with time management or attention to task. Remember, all of these tools you have just seen may be needed by a student with a disability to accommodate a barrier presented by their disability. But for other students, they might just be lesson enhancements or temporary supports. The examples of assistive and instructional technology you have seen in this module are ways we can make learning math a more inclusive process. Remember our mantra for this series: all students can think mathematically. Sometimes a disability may provide an additional barrier in the learning process. Assistive technology can provide some additional access to those learners. Beyond that, we also need to focus on the inclusivity of our instructional methods. In the next module of this series, we will talk about math pedagogy and how the instructional practices can be either an inhibitor or, even better, a facilitator of mathematical learning. I have provided one example of a website about dyscalculia. I invite you to explore this website and resources and see where it takes you. This exploring down a rabbit hole approach to learning uses a contemporary learning theory called connectivism To help you keep track of your thoughts, you can use this QR code to make a copy of a Jamboard that will let you and your colleagues organize what you learn. In addition to the graphic organizer for your dyscalculia ideas, there's also an assistive technology activity where I give you a mini case study scenario of different students who may have trouble accessing the math curriculum. You and your colleagues should search online for potential AT solutions for these students that range from low tech to high tech.